Right, in this lesson we're going to look at Pascal's triangle and combinations and try and see the link between the two. So you should be aware of Pascal's triangle, a nice little pattern that we can create. So hopefully you remember that how you get the numbers from adding the two numbers above it. So that's all well and good, but imagine you want the 10th row, the 12th row, the 20th row of this. It would take a little bit of time to write it all out. So what we're going to try and discover now is how we can find a formula for each of these terms so that we can predict any of the next terms without working out any of the previous ones. Now before we do that we need to backtrack a little bit and remind ourselves a little bit about factorials. So factorials, 3 factorial there, you might remember is 3 times by 2 times by 1, which you could write as 3.2.1 like that as a product, which you could work out as 6. 5 factorial is going to be 5 times 4 times 3 times 2 times 1, and if you work that out that gives you an answer of 120. Now your calculator can work out factorials as well. I'll just show you for the TI where that is. So if I wanted to do 5 factorial, I type 5 in, go to the math button, and it's actually on the PRB, which stands for probability there. It's because we need to work out factorials often when we're doing probability calculations. Press enter there, 5 factorial, we get 120. So what I'd like you to do now is to work out these 4 factorial, 6 factorial and 7 factorial and check your answers with your calculator. Okay, pause the video and do it now. Okay, welcome back. So 4 factorial is 24, 6 factorial you could write as 6 times by 5 factorial. The reason I do that is obviously because I've just worked out 5 factorial is 120, so that's 6 lots of 120, 720, and I've just done 7 factorial using the calculator, that's 5040. Now then, before we discover the secrets behind Pascal's triangle and how to describe it with factorials, I just want to go a little bit further and do some other calculations with them, just in terms of being able to simplify them. So 5 factorial divided by 3 factorial is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, and just in a way that we can speed that calculation up and do it in our heads without having to use our calculator, because you'll notice that there's a lot of repetition there. Divide through by 3, divide through by 2, and divide the numerator and the denominator through by 1, and that leaves you with 5 times 4, so that's 20. Okay, so without using a calculator, what I'd like you to do now is work out these. Pause the video and I'll come back with the answers. So 6 factorial over 3 factorial, you might have worked out that you'll end up with 6 times 5 times 4 because the 3 factorial cancels out, so that's 30 times 4, which is 120, and 10 factorial over 8 factorial, so you will just be left with 10 times by 9, which is 90. Okay, so back to Pascal's triangle, and I've just put these in rows here to help us out. So actually we call this row here the 0th row, which is quite important in terms of describing it later on. So we call that the 0, the 1st, the 2nd, the 3rd and the 4th row. Now how do we describe this number here? Right, well the number 6 comes from this. It's actually 4 factorial over 2 factorial 2 factorial. Okay, so that's 4 times 3 times 2 times 1 over 2 times 1 over another 2 times 1, and you'll see that those two cancels out with the 4 and leaves us with just 6. Right, I've added another row to Pascal's triangle there, and I want to know how I get this number here. So that's in the 5th row. So that's going to be 5 factorial over 2 factorial, y2 we'll see in a little while, and then 3 factorial. I'll show you where those numbers come from. So let's do that calculation. So 5 times 4 times 3 times 2 over 2 times by 3 times 2. A lot of that should cancel out. 3, 2 disappears. The 4 can be divided by 2, so that leaves me with 10. Okay, so let's carry on. Let's try this. Oh, there's a mega Pascal's triangle there, and I want to know where the number 56 comes from. So row 0, 1, 2, 3, 4, 5, 6, 7. That's actually row 8. So, and we've got, well, this is where the other numbers come from. So it's the 0, 1, 2, third entry. So that's the third across. Notice again we start with 0, 0, 1, 2, 3. So we're going to have 8 factorial over 8 minus 3 factorial. You see where the 3 comes from here. 3 factorial. Okay, so the 8 factorial is because it's the 8th row. Remembering we started at row 0. And then we've got the third term in. So 0 term, 1, 2, 3 term. Okay, and you can work that one out. We've got 8 factorial over 5 factorial, 3 factorial. So we're going to end, let's cancel those out straight away. So I've got 8, 7, 6, cancels out with the 5 factorial over 3 times 2. 3 times 2 is 6, so I've just got 8 times by 7, which is our number 56. Okay, let's try another one. Where does this number 45 come from? Okay, so which row is it? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's the 10th row. So 10th row and the 0, 1, 2 second term. So we're going to look at 10 factorial over 10 subtract 2 factorial 2 factorial. So that's 10 factorial over 8 factorial 2 factorial, and then all of that's going to cancel out to leave us with 10 times 9 over 2, which is 45. So all of these we can work out quite easily without a calculator. Well, I say all of them, some of them to the middle do take a little bit more work. So what we're going to look at now is just formalize that a little bit and look at some of the notation. So if you remember, the number 6 came from 4 factorial over, well, I could write that as 4 minus 2 factorial 2 factorial. And actually we call that a combination. And we could write it as 4C2. Or you might even see it as 4-2 written like that. And again, we can use our calculator to work that out. It's there for you. So if we go to on, math button again, and it's on the probability here. There it is, look, NCR. Now the key thing here is to remember that you've got to put a number in first. In this case the number 4 first, so it's easy to forget that. So I'll put the 4, so math, and the probability, CR, and then the number 2. So it's called 4 combination 2, should give me an answer of 6. There it is. And let's look at another one. The number 10 we got from 5 factorial over 5 minus 3 factorial 3 factorial. We could write that as a combination. That's 5C3, or you could write it as 5-3 like that. And then on the calculator, therefore, we put 5 in first, math, the probability button, NCR, and then put our 3 in, gives us an answer of 10. Right, so on your calculator right now, I would like you to work out 8C3 and also 10C3. Pause the video and I'll come back and I'll give you the answers. Right, welcome back. So 8C3 is actually what we found before here. 8C3 is that one there, so you should have got an answer of 56 for that. and 10C3, well, it should have given us this number here. Sorry, that's 10C2. Should have given us, therefore, should be the next one. First, second, it should be 120. 10C2 there. So the formula for these combinations, we could write as like this. So NCR, or could write it like that. It is n factorial over n minus r factorial r factorial. So if I was asked to work out 6c4, then I'm doing 6 factorial over 6 minus 4 factorial 2 factorial. So it's 6 times 5 times 3. Yeah, I've just gone wrong there, haven't I? Yeah, let's just correct that. So that should have been, of course, 6 minus 4 factorial 4 factorial. So we've got 6 factorial over 2 factorial 4 factorial. This is the bit that's going to cancel out. So we're going to have 6 times 5 over 2, which should be 15. Now in terms of our Pascal's triangle then, that is row 6 and then the term 4. Let's have a look. Row 6, so 0, 1, 2, 3, 4, 5, 6, so it's this row, and term 4, so that's 0, 1, 2, 3, 4. Should be the number 15, which is what we got there. So what you do need to do now is get a little bit of practice of calculating with combinations.